What's up, guys? Today we are going to practice. So we're going to practice binary search today. And we were I'm almost done with the 1200 sheet, and I am also, give me a second. Alright, so we will first complete yesterday's problem. I'm also going to build an app for my game creator. I'll try to build something because it's everything.
Hello guys, I am Hitesh Tripathi and this is a tutorial video for problem
n and m, where both of them are of order 10 to the power 5. Here n is the number of workers that we have, and m is the number of tasks that we have to do. So let's say the tasks are a1, a2, a3, so on up to a of n. Every task has a preferred worker, right? Every task has been given a preferred worker. For example, let's say preferred worker of a1 is 3. So if 3 tries to solve task a1, it will take him 1 hour. So if a preferred worker solves a task, it will take him 1 hour. On the other hand, if some unpreferred worker, let's say if worker number 5 tries to solve this task a1, it will take him 2 hours. So if unpreferred worker tries to solve a task, it will take him 2 hours, right? So we have these n workers, and we have been given m task where every task has some preferred worker, and we have to efficiently assign these n workers to this m task and do this task do this task in minimum amount of time. So we have to find the minimum amount of time that is required to solve these tasks using n workers. And if you have seen my previous videos, I have always talked about that if you have to minimize something, you have to maximize something, the very first thing that you think about is binary search. So here again, we have to find a minimum or a maximum. So again, you should think about binary search. I think there is also a greedy approach to the problem, but I won't recommend to solve these using greedy, because greedy will only help you in one or two problems. But if you work on your binary search, you will be able to apply binary search to a lot more problems, and that will help you a lot more in your future, right? So I will only talk about the binary search solution. If you want to see a greedy solution, I will recommend reading some more solutions on under the comments or somewhere else. Yeah, so let's start with the binary search solution. How can we apply binary search on this? So first of all, let's try to draw a graph, and let's see if we can apply binary search on this. So if I try to draw a graph, here on y-axis I will say if we can do all tasks, if we can do all tasks, right? There is my answer, right? That is the minimum amount of time. Obviously my answer is the minimum amount of time, right? So if my time is less than answer, I will not be able to do all the tasks. So the answer on this side will be no, right? So for example, if my answer is x, then I will not be able to do all my tasks in x minus 1 time, because if I am able to do all my tasks in x minus 1 time, then my answer will be x minus 1, not x, right? So on the left side of my answer, my value will be no, right? And now if you think about the right side, that is answer plus 1. If you are able to do all tasks in answer time, obviously you will also be able to do all tasks in answer plus 1 time, right? So on this side the answer will be yes. And as you can see, there is a clear line. Our answer divides these two blocks in no and yes, right? So you can easily apply binary search. You can easily apply binary search and find this answer, because it clearly separates your no and yes block, right? And this is how binary search works, right? So now the point is, how do you check if you are in the yes block or you are in the no block, right? So now we have to check no and yes. How do we find this no and yes? So how can we do this? So let's see. Let's say my current time. Let's say I am somewhere here, right? Let's say I'm trying to find some random time x, right? I am taking some random time x, and I have to tell if this x lies in the yes side or this x lies
So we are going to now re-attempt this problem. Okay, we are taking off. So laptop is silent. It's time to take off now. And anyways, we are going to now solve. I hope we can solve this now. So first thing we need to understand, this was a monotonic function. We could make a monotonic function. So this had a monotonic nature, which means that, let me show you. Let's say I have three people, okay, and four tasks. Person one is expert in two and second and third task. Person two is expert in the first task. Person three is expert in the fourth task. So let's draw these people on the y-axis. Okay, so y-axis is going to have our people, right? So person one, person two, person three. Then we then do this. Then we have on the x-axis the hours it took. So let's say person one did two tasks. He did task one first. Okay, it took him 1 hour. And then he did task three, which also took him 1 hour. Okay, so and similarly, person two did task one, and person three did task four. So this cost us 2 hours. Okay. Now, if I say that that can the task be done in 4 hours? Yes, it can be. Can the task be done in 2 hours? Yes, it can be. Can the task be done in 1 hour? The answer is no. Not all tasks can be done in 1 hour. Which describes the monotonic nature of this problem. Let's say I have n number of people, right? We have some number of people. We have person one, person two, person three, okay? And here are the number of hours each person takes. So 1 hour or 2 hours or 3 hours or 4 hours or 5 hours or whatnot, right? So what will this look like? Let's say person one takes he's expert in one task, completes this in 1 hour. This guy can complete two tasks. This guy completes three tasks, right? So this is just an example. Show you. And we are asked what is the minimum number of hours by which all the tasks can be done. So my question to you is, are all the tasks can all the tasks be done by 5 hours? Yes. Can all the tasks be done by 4 hours? Yes. Can all the tasks be done by 3 hours? Yes. Can all the tasks be done by 2 hours? And the answer is no. Here the answer is no, and here the answer is yes. Okay, So this describes the monotonic nature of this problem. And by monotonic, I mean a function. Okay, so we have a function of x, let's say, it is true for certain values, right? So we have it's true for some ranges of values. So it's true here and false for these values, right? And similarly, if we have a monotonic function, we can also call this a predicate function, honestly, monotonic function, which says that we have that is it possible to do this in x hours, right? So that can be our monotonic function, and this will be true for f of x is greater than equal to certain value, right? It's going to be true for all those values. It's going to be false for all the smaller values, and this is your monotonic function. So we will do binary search now, and how do we decide? How do we work on the predicate function now? Let's see. So the first thing to understand is that if a person is expert in a certain task, we will always give him that task, which means that if person 1 is expert in the second task, we will give him that task. If the person is expert in the third task, we'll give him that task, right? If the second person is expert in a certain task, we just give him that task and we say him to do it. Now here's the problem. Here is the problem. Let's say that we have to get this done, get all tasks done by x hours. Okay, so we have person 1, person 2, person 3, and we have to solve all the tasks by x hours. So, and I'm going to give you an example. This is 1, this is 2, this is 3. Okay, so x is 3 in this case. I'm just giving an example right now. So if person 1 can do the following, person 1 can do task 1, task 2, task 3, task 4 very quickly, and person 2 can do nothing basically, or we can say he can only do task 5. Person 3 can do nothing. He's expert in nothing. So now we have to check whether or not is it possible to get this done by x hours. How do we do that? First of all, we will say, all right, person 1 can do the tasks he's an expert in. He's expert in the task 1, he will do the task 1. He is an expert in task 2, he will do the task 2. He's an expert in task 3, he'll do the task 3. All right. Now here's the problem. We can't assign task 4 because then we're going to exceed the limit. We're going to exceed x hours. So we're going to say, okay, the expert can't handle this problem, so we will try to give this to somebody else who is not an expert and who also has the spare time. Okay, now we have marked this basically. And then we come to 5 and we say, okay, can we so does person 2 is person 2 free? Yes, he is free, so we can just give him the task 5. Now he has a lot of time on his hands, right? And we can say, okay, he has time, so we can adjust him accordingly. And similarly, person 3, this person right here also has a lot of spare time on his hands. This right here, this is spare time, this is spare time, right? This was the task we were not able to complete here. So is spare time available to accommodate these tasks? So the answer is yes. So we'll need only 2 hours here. Okay, we will only need 2 hours to complete this missing task. And here we have 3 and 2, 5 hours. So we have 5 available hours and we only need 2 hours to complete this task. So yes, it is possible for 3. Now let's say that we move backwards. The logic will remain the same. If we try for x equal to, let's say this right here, what do we do then? So we will first see, okay, task 1 done, task 2 done. We can do task 3 here. We can't assign this to him, so we'll mark this. We'll mark 4 as well. Then we go to 2. We say, okay, 5 done. Then we said he has this much spare time. All right. We go to 3. We see how much spare time do you have. He says I have this much spare time. Okay, good. Now what we say is how many tasks are remaining that will be solved by non-experts. Okay, so we have two tasks remaining, and if this is solved by non-experts, it's solved by a noob, I guess we can call this a noob. So noob will take 4 hours. Okay, how many hours do we have here? We have 2 and 1, 3 hours here. There's one more edge case that I forgot to mention. That is that he does have the spare time, right? This right here. But that doesn't mean that he can solve a certain task in this hour, right? So we need to understand that these blocks right here, we can't solve a task, can't do it even. So there can be an edge case where you say that 3 can also solve this, and he has 1 hour spare hour here. He has 2 has 1 spare hour here. The total number of spare hours are 2, but they are scattered in such a way that we can't complete a single task. A single task will come here, it will exceed here, it will exceed here, right? So in this case, although the spare time is 2 hours, but that doesn't mean that we can complete any task because it's scattered in this manner. So how do we go around this? My logic would be to subtract this by this and divide it by 2 and then multiply it by 2 again. Or maybe we can do something like okay, I think this makes much more sense. Or we can just divide this by 2, right? And once we divide this by 2, we can just understand that we can yes, I get it. So I'm going to say what is the worst case scenario? We have m tasks, right? So we have m tasks. And we give all of this to a non-expert. So if we give this to a non-expert, he will take 2 times m hours, right? That is our worst case scenario. So in upper is going to be 2 times m, and in lower is equal to 0, and in answer is also going to be 2. All right, now what we do, we say for in I equals 0, I equals m plus implement the frequencies. We can just use a vector, I believe. So I'm going to just say a vector comma a vector int of frequency of size n plus 1. Frequency of x gets incremented. Now once the frequency gets incremented, we go about solving our binary search. So we're going to say while low is less than equal to I, lower is less than equal to upper, we're going to say if is possible with the value of if it is possible with the value of mid, then we say answer is equal to minimum of answer of mid. Then we say, so this means we are in the yes region, right? We can try and push in this direction and see if a yes region exists further back. So to do so, we will move our upper bound to -1 and try again. So then we else what do we do? If it's possible returns false, we're going to move we're going to push forward our search, right? So we're going to just discard the left half and push forward and look for the yes region, right? So we're going to get lower is equal to then we can have in this passing boolean of is possible, so it's possible, and we're passing in int h, which is the number of hours. Okay, and we also say vector int and so we're going to say got to pass n as well. We have to also pass n. So we pass these parameters, and then we say for int I is equal to 1, I is less than equal to n, I plus plus, and for each we have to say int tasks, let's say tasks, I'm going to say int so what would be the right variable name in this scenario? We can say extra right now we say that if frequency of this number, so if the frequency of tasks is greater than the number of hours, what do? We are going to increment our extras with these many tasks. Frequency number of tasks minus hours, so it's going to give us the extra hours else. What do? We say that this guy has room for doing these many extra tasks. So how much room does he have? That will be determined by our the hour minus the number of tasks he has, right? So it's going to give us the remaining time in terms of like the hours, and then the possible task will be divided by 2 because it will cost him 2 tasks to complete 2 hours to complete that extra task. So return extras are less than equal to possible. That's our predicate function. There we go. So let's submit this now. Now we will decide whether or not to continue with binary search or to continue with our regular practice. So I am thinking we can just do practice for now, and we will see if we have the time for extra binary search problems. I think binary search is very easy to identify, but it takes a lot of time, a lot of practice. We'll start our break time now. All right, let's start in ThemeCP, I guess. Very nice. C. So we have for an array of integers which find its equality characteristic as the array so we have let's call this one This is not true. So this is 0. This is 1. Oh, this is 1, so what does that mean? It's going to be equal to its neighbors, but it's not equal to its neighbors. Is there a shorter way to solve this? Mm, that's just what we know. We're going to start with this right here. So it's going to start with second element, and also going to end on the second last element. So it's going to be like now we're going to see. and then we say a of if it is equal to 1, this means that it's going to be 1, otherwise it's going to be a different number, which is or now we say that if b of I is equal to 1 and this connection happens, which is a of I is not equal to a of, then say else what do? We Isn't really a problem. Can't understand why I can't get this. Mm.
So hey guys, welcome to video. Problem A, was there an array code versus round 174 educational. ठीक है, तो इसमें हमें एक एरे गिवन है बेसिकली ए, और इससे हम एक इसका इक्विलिटी कैरेक्टरिस्टिक एरे बी बना रहे हैं जो कि बस इन एलिमेंट्स होगा. ठीक है, स्टार्टिंग वाला फर्स्ट एलिमेंट छोड़ दो और लास्ट वाला एलिमेंट छोड़ दो. ठीक है, अब हमें क्या करना है कि देखना है कि अगर इस एलिमेंट के लिए अगर इसका लेफ्ट और राइट नेबर इसके इक्वल है तब तो 1 आएगा, अदरवाइज 0 आएगा. अब इस एलिमेंट के लिए देखें तो इसका लेफ्ट वाला 1 है और राइट वाला 2 है, जो कि इसके इक्वल नहीं है दोनों, तो यहाँ पे 0 आ जाएगा. फिर इसके लिए दोनों इसके इक्वल है लेफ्ट राइट में, तो इसके लिए आ जाएगा 1, और इस 2 के लिए यहाँ पे दोनों डिफरेंट है, तो यहाँ पे आएगा 0. 3 के लिए भी सेम, यहाँ पे 0 आ जाएगा, क्योंकि इधर 2 है इधर 3 है, इसमें भी 0 आ जाएगा, क्योंकि इधर 3 है इधर 4 है, इसमें भी 0 आ जाएगा.
In this Domestico course, you will learn the essential techniques for sketching industrial product design using
क्योंकि इधर 3 इधर 4 है, इसके लिए आ जाएगा 1, क्योंकि इधर भी 4 है और इधर भी 4 है और ये खुद भी 4 है. ठीक है, और इसके लिए क्या आ जाएगा, इसके लिए आ जाएगा 1 फिर से, और इसके लिए हमें कैलकुलेट करना नहीं है. तो ये हो गया हमारा इक्विलिटी कैरेक्टरिस्टिक एरे भी. ठीक है, तो इसका हमने कंस्ट्रक्ट कर दिया ये. बट हमें इनपुट में ये एरे गिवन है और हमसे ये पूछा है कि क्या हम उसके लिए कोई एक वैलिड एरे बना सकते हैं या फिर नहीं बना सकते. हमें ये बताना है, ये हमें गिवन है और ये हमें बनाना है. ठीक है, इसका ऑफकोर्स साइज कितना होगा, -2 होगा. इसका साइज अगर n है तो हमें -2 लेंथ का दिया हुआ होगा. ठीक है, और हमें बताना है कि हम इस n लेंथ का कंस्ट्रक्ट कर सकते हैं या फिर नहीं कर सकते. तो यहाँ पे एक चीज देखते हैं कि हर एलिमेंट यहाँ पे जैसे ये ना अपने करंट एलिमेंट अगर आई पोजिशन पे i-1 और i+1. ठीक है, यहाँ पे एक 3 लेंथ के एक सब एरे मान सकते हैं ना, उसके साथ बाउंडेड है ऑफकोर्स, क्योंकि हम प्रेस करंट एलिमेंट को उसके प्रीवियस और नेक्स्ट एलिमेंट पे चेक करें. ठीक है, तो हमें बस ये देखना है कि अगर देखो हमें 3 लेंथ का सीक्वेंस चेक करना है. ठीक है, उसमें से कौन सा वैलिड सीक्वेंस है कौन सा वैलिड सीक्वेंस नहीं, उस हिसाब से जैसे इसमें देखें तो ये सब वैलिड सीक्वेंस है, क्योंकि यहाँ से हमने इसको बनाया है गिवन एरे से ये बनाया, तो उस हिसाब से हम देख सकते हैं कि 010 वैलिड सीक्वेंस होगी. ठीक है, और 100 भी वैलिड सीक्वेंस होगी, और 000 भी वैलिड सीक्वेंस है, और 001 भी वैलिड सीक्वेंस है, और 011 भी वैलिड सीक्वेंस है. ठीक है, तो उस हिसाब से हमें चेक करना है कि कौन सा वैलिड सीक्वेंस नहीं है. तो अभी देखो हमारे पास या तो बना सकता है या फिर 0 आ सकता है, 3 पोजीशन है. ठीक है, अगर हमारे पास 0 0 आते हैं तो ये बनेगा, अगर तीनों 1 आते हैं तो हमारा ये बनेगा. ठीक है, या तो 2 1 आए और 1 0 आए, तब क्या होगा, 1 1 0 बन सकता है, 1 0 1 बन सकता है और 0 1 1 बन सकता है। ठीक है, ये 3 बन सकते हैं इस केस में, और इस केस में ये बन सकते हैं। और अगर हमारे पास 2 0 आए और 1 1 आए, तब क्या बन सकता है,
Hi everyone, welcome to the PCB of today's educational code forces round 174. I am Pradyum and today we'll discuss the first 4 problems A to D. And but before that, I would like to tell you about the all new CP31 sheet by TLE Elevators. For those who are not aware, this sheet consists of 31 handpicked problems, each rating from 800 to 1900, carefully chosen so that each problem teaches a unique idea. Our sheet has now been upgraded with a new interface. As you can see, automatically syncing your process with your Codeforces account. So you can just connect your account and it will sync your process. Right? There's also a leaderboard section, so where you can see your friends and your own problem solved and compare, and you can compete with your friends as well. Added to this, every week 7 to 8 video solutions will be uploaded. So no more wasting time searching for the right problems. The link to the sheet is in the description of this video. So yeah, let's get started. Okay, so I'll open the code forces just a minute. Yeah, so this was today's contest. And the first problem it is called was there an array? For an array of integers a1, a2 up to an, we define its equality characteristic as the array b2, b3 up to bn minus 1, where bi is equal to 1 if the ith element of the array is equal to both of its neighbors. So if a2 is equal to a1 and a3, then b2 will be equal to 1. Otherwise, b2 will be equal to 0. Okay. For example, the array 1, 2, 2, 2, 3, 3, and 4, 4, 4, 4 has the equality characteristic 0, 1, 0, 0, 0, 0, 1, 1. So basically, what you do is for each index from 2 to n minus 1, you just compare both of its neighbors. And if it is equal to both of its neighbors, then it will be 1. So since this 2 is not equal to this left neighbor, the first element, that is b2, is not equal to 1, it is equal to 0. You are given the array b2 to bn minus 1. Your task is to determine whether there exists such an array A, for which the given array is the equality characteristic. So basically, you have been given the array B, and you have to figure out that can there be any array A, that can there be any array A such that this is the equality characteristic. Okay, so that's the first problem. So yeah, let's try to think about it for just a minute. So let's look at the samples, or let's just look at this array only. So let's say this was our input, then of course the answer will be yes, because this is one of the possible arrays that we can make, right? But okay, let's see how to prove that. Like let's try to derive the answer by ourselves. So 0 1 0 0 0 0 1. So okay, 0 1 0 0 0 0 1 1, right? So this is b2, this is b3, and up to this is b of 9, right? Since there are 8 elements. Is my voice audible? Okay, right. So b2 to b9, right? Now let's say we have to make the array A. So array A will contain 10 elements. 1 2 3 4 5 6 7 8 9 10, right? So the first element, let's say first element anything. So let's keep it 1. All right. Now what we know is that this b2 is equal to 0, right? So what that means is that whatever the element is here, either it is not equal to the forward one or it is not equal to the backward one, right? So let's just assume that it is not equal to the backward one. So let's say it is 2. Because why am I doing that? Because the b3 says that these two actually are equal. Like because b3 is 1, that means that 3 is equal to 4. Like the index 3 is equal to index 4, and also the index is equal to index 2, right? So actually, better to explain this would be like, just look at all the ones. Look at all the ones. This one, and this one. Okay. So what does this one say? This one says that okay, this one says that these three are equal, right? A2, A3, and A4 are equal. Then this one, the B8 says that this is 9, right? So 8. These three are equal. And B9 says that these three, like this, and this, these three are equal. So I'll just do this, right? So actually here there is no contradiction. So what you can just do is just make all these four equal, all these three equal, I mean, and just like make all the others are equal. Okay, so let's say I make them like this. So one, we need to make these three equal. So 2, 2, 2. Then let's say we have 3. Then we have 4. Then we have 5, 5, 5, and 5. And now as you can see that no zeros are actually like contradicting, because wherever I did not draw this curve, so there is a 0 there. But in that case, like there is no contradiction, because let's say on B2 we have 0. So this is the second element. So I'll number this 1, 2, 3, 4, 7, 8, 9, 10. Yeah. So on the second one we have the left side as like not equal to the second index. So 1 is equal to 2. So therefore this 0 is not contradicted. So this 0 is satisfied. Then all the ones are satisfied. So that's what we have ensured, right? And then this B4 should be 0. So that means that this fourth element should not be equal to either third or fifth element. So it is not equal to fifth element, right? So as you can see that all of the zeros are satisfied. So that's one way to solve this problem. Like we can just look at all the ones and ensure that they are satisfied. Okay. And then we can just check for the zeros. We can just check for the zeros that okay is like are they satisfied or not. So first of all we'll just put equal numbers on these ones, and for all these zeros we'll check that are satisfied or not. So that is one way. But there's another way actually. That is because samples. Like okay, so let's think that when would there be a contradiction? Like answer no, how can that be? Like when you are reading this problem, you might think that how can the answer be no? Like why can't I just create an array like this? That since the first, like I just look at all the ones, and wherever there is equal, I'll just keep them equal and others non-equal. So how can the answer be no? So for that, let's look at samples. So the third sample, as you can see, it has the answer no. So why that is? Let's think about that. Okay. So the array is 0, 1, 0, 1, 1, 0, 0, 1. 0, 1, 0, 1, 1, 0, 0, 1. Okay. Yeah. So so let's try to do the same thing that we did above, right? So I'll just make a new array. 1, 2, 3, 4, 7, 8, 9, 10. 1, 2. All right. So here I need that the third element should be equal to, like the third element is 1, right? So these should be equal. Then this 1, 1. So on 2, 3, 4, 5, 6, 7, 8, and 9. So on third we are equal. On fifth we are also equal. So fifth is equal to 4 and 6. Then 6 is equal to 5 and 7. So 6 and 7. And then 9 we have 8, 9, and 10. Right? But now the problem here is that
My business is thriving. So when I heard that ClickUp is the AI work platform,
on this fourth one, it is saying that either one of these sides should not be equal, right? But as you can see that all of these have become equal. So definitely we cannot, like, this is a contradiction, right? Because these two ones say that 2, 3, 4 has to be equal and 4, 5, 6 has to be equal. But this 0 between them says that this 4 should not be equal to either 3 or 5. So that's a contradiction. We cannot satisfy that condition. So in general, if you can see, in general, if we have any 1, 0, 1 in the B array, if B has some numbers and then it has 1, 0, 1 and then it has some numbers, then what does that mean? Then that let's say this is the index 5, this is 6, and this is 7. So this one means that 4 should be equal to 4, 5, 6, 7, and 8. So here this one wants that 4, 5, 6 should be equal, and this 7 wants that 6, 7, 8 should be equal. But that means that all 5 of these are equal. So definitely this 0 will not be satisfied. Okay, so that's why this is a contradiction. So my point is that if anywhere you see 1, 0, 1, like if anywhere in the array B you see a 1, 0, 1 happening, then definitely we can say that it is not possible to construct the array. And otherwise you can just construct the array like I told you. So wherever there are ones, just try to satisfy them, and automatically zeros will be satisfied. Other than the case where there is a 1, 0, 1. So the final solution is to just iterate through the array B and check if there is a 1, 0, 1 or not. So if there's a 1, 0, 1 in the array, then the answer is no. Otherwise the answer is yes. So why actually otherwise the answer is yes? Because let's say if 1, 0, 1 is not there, let's say 1, 0, 0, 1 is there, then what does that mean? That okay, that these three are equal, and so this is the one, and here is the one. So these three are equal. But it says nothing about these two. So these two can be different. That's why there is no contradiction for 1, 0, 0. Okay. And if there is a 1, 1, then also no contradiction, because like this is 1, this is 1. So these two should be equal, and this one says that these two should be equal. So all four have to be equal. So that's like that's no problem. So the only contradiction happens in 1, 0, 1. That's why you can just iterate through the array B and check if there is some 1, 0, 1 or not in the array. Okay. So yeah, that is the final solution. So is it clear to everyone, the logic? The time velocity of this would be just O of n, because we are just iterating through the array like once. We have to just make a loop of n and then check if. So basically what we'll do is b of array n minus 2, right? b of size n minus 2. So we'll iterate from, let's say this is b. So first we'll have a pointer starting at 0. So let's say this is I. Then we'll check if bi is equal to 1, bi plus 1 equal to 0, and bi plus 2 equal to 1. So we'll check this thing